Hey viewers, and welcome to the second video for Unit 4. It's called Proving Triangles Congruent. We don't really have any notes to go with this. However, we do have a summary that you will find if you look on the Google Drive, and this is what it looks like, so you know what you need. It's basically just a summary of what I'm about to teach you, okay? So, I'm going to show you on Gizmos. I just want you to watch. So, what happens if we've got two triangles, okay, and I don't put any restrictions on the lengths of the sides or the measures of the angles, right? They definitely, I could easily make them not congruent, right? Well, what happens if I restrict one of the angles so that it has to be congruent? Do now the triangles also have to be congruent? Let's see what happens. I'm going to drag, oh, well, look at that. That angle that we have restricted does not change, but I can still make the triangles not congruent. So having just that information, one angle is congruent, is not going to be enough information to prove that those two triangles are congruent. What if I restrict two of the angles? Is that going to guarantee me triangles that are congruent? Let's check that out. So we've got two triangles that have two angles that are congruent. However, these triangles they're actually similar, same shape, different size. It's possible. So that still is not going to give us enough information to prove the triangle's congruent. Well, what if I make all three of the angles congruent? The sides can still be different lengths. We can still have similar triangles. So on the summary, down at the bottom, one of the not possible ways, it's not possible to have, if you're given the information that you have three angles that are congruent, just because the two triangles look congruent doesn't mean that they will be congruent. So that's not a way to prove triangles congruent. That's why it says not a theorem, angle, angle, angle. Okay, let's go to the next one. All right, well, let's move on to sides. Well, what if I restricted only one of the sides? Can I guarantee that the two triangles will be congruent? No. What about two sides? No. Just because we've got two triangles that have two sides that are congruent to each other isn't going to guarantee those two triangles are congruent. Well, what about three sides? Three sides congruent. Check that out. Look at that. That guarantees those two triangles congruent. No matter what I do with the angles, they are going to remain the same if all three sides are congruent. And that is one of our theorems on here. Here it is. Side, side, side. It's the second one. If three angles of one triangle are congruent to sides. If three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. That's a theorem. All right, let's do something else. Let's see what else happens. What if I restrict one angle on one side? Okay, and you'll see, nope, don't have to be congruent. Well, I'm going to leave the next one and skip over it. We'll do that one in just a minute. This is called SAS, side angle side. Now, the way this is written is that the angle in the name is in between the two S's, the sides. So in the diagram, your angle has to be in between the two sides. Now take a look. Look at SAS. That guarantees the two triangles are congruent. So that is another theorem on your sheet. In fact, it's the first one. If two sides of and the included angle. Included just means that the angle is in between the two sides. Okay, if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So let's move on. All right. So we did SAS. All right. What about ASA? We have one side in between two angles, so we call that angle, side, angle. That looks like pretty much guarantee right there. We get two congruent triangles, so that's on our list as well. Where's my list? Okay. So angle, side, angle. There it is, number 4. Okay, now notice the S in the name is in between the two A's. So that means in the diagram, the side has to be in between the two angles. That's why they call it the included side. Okay? Moving on. AAS. Well, this is different because now we have two A's, but the S is not in between them. You see how in the example here, we have two angles, but the side is not included? It's not in between? That is a way to prove triangles congruent. We cannot make them not congruent. So, on our list, here it is. Now you can write this as AAS, or you can write it backwards SAA. It's the same thing. Alright, so we've done almost everything here. Except this one. Now, this is called ASS or SSA, if you write it backwards. I think the best way to remember this is not a way to prove triangles congruent, is to remember that ASS spells a bad word. Okay, so if you ever write that, if I ask you for, what's the way that to prove these two triangles congruent, you would never write ASS or SSA, because that's not a way to prove triangles congruent. Here's why. Watch what happens. Most of the time, the triangles are congruent. However, you can create a counterexample, and we're going to talk about why this happens once you get to pre-calculus. Okay, but for right now, all you need to know is if you have two sides right next to an angle, we've got a counterexample. Just because we've got two sides right next to an angle doesn't mean the two triangles will be congruent. So that's why on your summary sheet, which is here, all the way down at the bottom, not possible, one way is angle side side. Just because the two triangles in the pictures look congruent, if you're given this information, ASS or SSA, we don't know that those two triangles are guaranteed congruent. Okay? Now, I think I've done everything in this one. The last one I want you to look at is the other gizmo. Okay, I'm just going to pull this up, and I'm going to show you the last one, and this is called hypotenuse leg. I won't go through all this. Hypotenuse and one leg congruent. Right triangle. If you have a right triangle, okay, that guarantees that right angle is going to be congruent in both of those triangles. Well, what happens if we have the hypotenuse, which is the side across from the right angle, and also an additional leg, and it doesn't matter which leg, okay? In this case, we have leg AB is congruent to leg DE, or we could also have leg AC is congruent to DF, okay? But those two triangles are congruent. So, that's your last method for proving triangles congruent on your list, HL. So if you see a right angle, I mean, it could be SAS. If that side is right here at NL, the angle doesn't have to be a right angle in SAS. Where's SAS? Here. Side angle side. Okay, but in this case, that's not a right angle. So just be careful. If you see a right, you can't use HL unless you have a right angle. It won't necessarily be HL. It could be something else. But in order for it to be HL, you've got to be working with right triangles, because the hypotenuse is only inside a right triangle. And that is all for now.